So we're finally going to learn about logarithms today. They're very important in solving equations where your exponent is unknown. So let's get a little intro to logarithms and we'll tackle that whole concept of solving for unknown exponents tomorrow. Let's just learn about logarithms today. So what is a logarithm? A logarithm is the inverse of an exponential graph. All right, so what we have down here is an exponential graph. So that's a basic one. It's a 2 to the x, so let's graph it. Well, I like to start off with 0 because 2 to the 0 power is a nice easy answer, 1. 2 to the first is 2. 2 to the second is 4. Let's give one more. 2 to the third is 8. And then we know when we start going into the negatives, we're just going to get fractions. We're not going to get negatives as answers. If I connect the dots, there, we have an exponential graph. So before we look at a logarithm graph, let's just go over the 3 basic properties here of this. Well, we have an asymptote. That's the that is the x-axis, or the equation y equals 0. Remember, we get very, very close to this, but we never touch it. A domain would be all reals. I can put any number I want in for x. What's restricted is the range. We can see by our picture that our range gets very close to the lowest number 0, and then that our graph grows and goes on to infinity. So now, where does this logarithm stuff come in? Well, we take the inverse by switching the x and y values. Thus, we're flipping this line over the line y equals x. So let's get a y equals x line on here. And let's have that stand out a little bit by making it dotted. And if we were to flip over this line, these points, remember, instead of the point being 0, 1, we switch x and y, so it would be 1, 0. And instead of this point being 1, 2, it becomes 2, 1. And instead of this point being 2, 4, it becomes the point 4, 2. And instead of this point being the point 3, 8, it is the point 8, 3. And likewise over here, this is the point negative 1, a half. Will this be a half negative 1? So when we do this line, this is what the logarithm to 2 to the x would look like, the inverse of it. So let's look at its asymptote. Well, its asymptote is now the y-axis, or the equation x equals 0. Its domain is no longer all reals. I can only put in numbers 0 and above. And its range, well, now its range goes into the negative. Its range is, well, I can get all real answers. And if you see, a logarithm is the complete inverse to an exponential. We switched x and y. Everything switched. Get it? Asymptote was x-axis, now it's y-axis. The domain and range flipped. The range of an exponential graph is now the domain of a logarithm, and the domain of an exponential graph is now the range of a logarithm. All right, so that brings us to our next question. What's the equation of this blue line? All functions must be in terms of y, because we want to see what the independent variable x does to y. So this was y equals 2 to the x. And if I did the inverse of that, well, that means switch x and y. X equals 2 to the y. And there's where our problem arises. It's solved for x. It's not solved for y. Well, we write that a new way. Y equals, and here's your new word, log 2x. Yes, that 2 is a subscript, which means it is written below the line. Just like this y right here is a superscript, which means to be written above. You must clearly show me that that 2 is sub. Please don't write like this. I have no idea what you're writing. I get this a lot too. No. That means something else. Clearly write so that I can see the difference between super and sub. So, upon further inspection, you are going to learn that logarithm is a fancy word for exponent. So these are the parts of a logarithm you must learn. That subscript is our base. Our power is x, and our exponent is y. And it's very clear that you understand the difference. We went over this when we were doing exponents. We often say 2 to the third power is 8. But in this case, it's not right. We never really were saying it right. This is an exponent. 8 is a power of 2. And of course, 2 is the base. So for example 1, 2 to the fourth can be written in logarithmic form as log base 2, 16 equals 4. What? Okay, well, this is what we got here. This is how I want you to think about it. We need to learn how to write logarithms. So in your head, you kind of envision a template. Base is the easiest thing to know. We know that. So down there is 2. Where kids get confused is where does the 4 go and where does the 16 go? Well, remember, when we come back here, the exponent is after the equal sign. And the power goes in here. There's a couple of ways to remember it. You're going to hear me referring to it as rolling the log. So that you should be able, in your mind, to see that roll. That you read it 2 to the fourth gets you 16. Now that's a stupid way to remember it. If it is, great. It's a silly little way. But the real reason what they want you to read this as, what is the exponent of 2 that gets us 16? That's how you're supposed to say log. So instead of saying, what is the exponent of 2 that gets us 16? Well, the exponent is 4. We replace this entire phrase with the word log. The exponent of 2 gets us 16 is 4. Okay, so let's get in some practice of how to rewrite exponents in logarithmic form. So I'm going to start with an exponent, 2 to the 6 equals 64. That's a true statement. To write that in logarithmic form, I have to understand that 2 is the base. Log is fancy for exponent, so the exponent is 6. And then my power is 64. And again, this equation is really read as, what is the exponent of 2 that gets us 64? Well, the exponent is 6. Number 2, the base is a. The exponent is -1. And the power or the answer is 1 over a. And again, we want you to learn this as, this is really saying, what is the exponent of a that gets us 1 over a? Well, the exponent is -1. So you can see now we use exponents in logarithms when the exponent is unknown. So we're going to give you a baby one right here. If I were to rewrite this, well, 3 is my base. My exponent is unknown, but my power is 81. So when I look at this, I want to say, what is the exponent of 3 that gets us 81? Well, that's easy. We would have just figured out that our answer is x must be 4. Likewise, you should be able to go backwards. So we're going to take these log problems and rewrite them in exponential form. So we understand that 49 was the base, but wait, 1/7 is the power. They didn't even give us a variable to hold x, because right, this is really saying equals x. What is the exponent of 49 that gets us 1/7? Well, you're going to learn how to solve this, but hopefully right now you can just do this in your head. You should see that 49 is related to 7 when we take the square root of it. So x must be at least 1/2, which makes sense. What is the exponent of 49? 1/2. Well, that means 7. To get 1/7, it must have been negative 1/2. All right, the next one. My base is b. My exponent is 3. And my power is 27. This is saying, what is the exponent of b that gets me 27? The exponent is 3. So my answer here, we're looking for the base. So what to the third power gets you 23? Well, in this case, it must have been 3. We've got another one where the base is unknown. Here's my base. 1/4 is my exponent, because that's the answer. Exponent is 1/4. And my answer is 5. So this is asking me, what is the exponent of b? Well, it's 1/4. They told me that. That gets me 5. Well, hopefully you remember from last chapter, this one's not so hard. I'm going to raise this to the 4th power. I shouldn't have said 4th power. I'm going to raise this to 4. That way I'll multiply and multiply to cancel out and get me b. And this is 5 to the 4th, which is 625. All right, so here's your summary. Logarithm is really a fancy word for exponent. Log sub b x equals y is read as, what is the exponent of b that gets us x? We need logarithms to solve equations where the exponent is unknown, and that's what we'll tackle tomorrow.